A rational function is any function that is a fraction where there is a variable on both the numerator and denominator. In this video, we're going to be looking at cases where both those variables are linear only. So the first one we're looking at in the form ax plus b over x. Well, when there's one thing on the bottom, we know that we can split that numerator into two parts, so we're going to go ahead and do that. So integrate 2x over x plus 3 over x. Well, that's nice and simple to simplify now. We get integrate just 2 plus 3 over x dx. And both of those integrate relatively easily. 2 integrates to 2x, and 3 integrates to plus 3 ln x plus c. Number 2, a bit more complicated. We've got some nonlinear terms in our numerator now, but it's still the same. We're going to be taking all of those numerator pieces and putting them over 2x. So we get 2x cubed over 2x minus 3x squared over 2x plus 4x over 2x minus 5 over 2x dx. Then we simplify. That will give 2 over 2 is 1, x cubed over x is x squared, minus 3x over 2, plus 2, minus 5 over 2 times 1 over x, dx. Technically they should be in brackets, but not so important. Equals, now we can integrate. That's x cubed over 3, minus 3x squared over, and dividing by 2, we get 2 times 2 on the bottom, which is 4, plus 2x, minus 5 over 2 ln x plus c. So when you're in this form, nothing too special. Split the numerator up and simplify and then integrate. Now in the form ax plus b over cx plus d, a little bit harder. And that's because we can't just split the top up with the denominator because there's multiple things on the bottom, and so it's not going to help. So there are multiple ways to do this. The way I'm going to teach you doesn't involve any sort of fancy algebraic division. We're just going to look at how can we make it sort of look like it's in the form above. Whereas above we had x on the bottom, and then we had something with that x there plus something else. Now we've got, in this case, 2x minus 1 on the bottom. I'm going to see how can I make that appear on the top. To do that, I'm going to first rewrite this as 2x minus 1 over 2x minus 1. Now on the numerator, we have 4x plus 5, which means we need to times our 2x minus 1 by 2 to get a 4x. If you were to expand that, you get now 4x minus 2. We want it to be plus 5, so we need to add a 7. Now we can split our numerator. That gives integrate 2 times 2x minus 1 over 2x minus 1 plus 7 over 2x minus 1, which simplifies to give just 2 plus 7 over 2x minus 1. That can integrate. 2 goes to 2x plus 7 ln 2x minus 1, because the power on the bottom of that fraction is just 1. But then we're going to divide by the derivative of that bracket, which is dividing by 2 plus c. Number 2, more of the same. We're going to firstly rewrite this as 2x plus 1 over 2x plus 1. Now I only have x on the top here, which means I've got to times this all by a half. And if we were to expand that, we get now x plus a half. We need it to be x minus 5, which means we need to subtract 5 and a half off that to get minus 5. We can now split that up. That gives us half 2x plus 1 over 2x plus 1 minus 5.5 over 2x plus 1. And simplifying one more time, that gives me a half minus, now we don't normally have decimals on top of a fraction. 5.5 as a fraction is 11 over 2. So that's minus 11 over 2 times 1 over 2x plus 1. And now we're in a form that we can integrate. Half integrates to half x minus 11 over 2 times ln of 2x plus 1, and then dividing by 2 to finally give us half x minus 11 over 2 times ln over 2 is 11 over 4, ln of 2x plus 1 plus c.